Hello everyone, my name is Cui Yigang, and my lecture is Vision System and Welding Robot based on Da-Xgboost algorithm. Abstract. In recent years, machinery and artificial intelligence have been rapidly integrated into modern industrial production. Its development and use in our country's intelligent production lines have also received more and more attention and have been achieved in many modern industrial fields. Welding is currently one of the most widely used technologies in some projects. Traditional welding mainly uses manual teaching and copying. The work intensity is high and the working environment is not good, which cannot ensure the effect of the welding work. The increasing maturity of machine vision technology provides a more superior product quality, high efficiency, automation and intelligence development direction for traditional welding robots in our country. Therefore, research on welding industrial robots based on mechanical and vision technology is of great significance. This article discusses the welding robot vision system based on the Da-Xgboost algorithm, summarizes some key technical problems of the welding robot on the basis of some literature data, and then introduces the basic composition of the welding robot. Finally, the welding robot vision system is designed, and the design welding robot vision system is tested to see if it meets the system requirements. The experimental results show that since the actual coordinates and the robot motion coordinates are obtained by manual measurement, there is a certain error. Even in this case, the absolute error of the entire vision system obtained is not more than 0.5 millimeters, which meets the requirements of system application. Keywords: Da-Xgboost algorithm, welding robot, vision system, absolute error. Introductions. With the progress and development of scientific technology and information theory such as network automation control technology, software and hardware technology, mechanical technology, image processing, and pattern recognition, robot vision is rapidly being applied to various industrial occasions, greatly improve and enhance the flexibility and automation level of robot applications in the original network. This vision technology is widely used in robots so that the robot can use the data received from this vision technology, such as the seam welding path of the workpiece, the size of the workpiece, etc. The robot system can perform coding annotations based on such data, so that the robot system can effectively make autonomous feedback to changes in the external world, and has specific perception and adaptation capabilities, thereby greatly improving the operation, automation, and intelligent management level of the robot system. For example, in the process of welding under the operation of a robot, some assembly errors can be measured by vision technology, and the error data can be transmitted to the robot so that the robot can be adjusted and modified in time to eliminate the deviation in use and improve the welding robot's performance. For the research of welding robot vision system, some researchers use narrowband and polarized visible light filtering technology to obtain CCD weld images to obtain characteristic weld elements, and use pattern recognition theory to locate and obtain actual welding and actuators. In recent years, with the development and emergence of some new algorithms, many researchers have widely applied this new algorithm to the task of visual recognition of welds. Some researchers have used the theory of multiple innovations to propose an improved Kalman filter algorithm for the detection of electronic welding positions. optimize electronic solder signal recognition and apply wave analysis technology to welding image processing and obtain good welding results. Some researchers have developed a new type of mobile wheel welding robot. This type of robot is mainly used in wheel welding to form the grill inside the cab. One of the biggest advantages of this type of robot is their small size and lightweight. Autonomous welding can be carried out directly even in a small space, and the initial welding position can also be automatically checked. When welding the corners of the grid, it is possible to coordinate and control the movement between the moving platform and the cross slider while ensuring a constant welding processing speed to ensure that the welding lenses align with the welding seam. Research on welding robot vision system and Da-Xgboost algorithm, problems in welding robot vision system, real-time control of the visual tracking system. The joints for exporting information images and tracking signals require computer inspection and visual supervision to have powerful real-time performance and high-precision control effects. However, due to the technical level of the optical sensor and only the introduction of some reliable control factors in the computer's data processing cycle and time will be affected in real time on its welding performance. Therefore, it is necessary to effectively speed up the feedback to the robot. For response speed, control accuracy must be sacrificed. The intelligence of the visual tracking system. Because the actual welding process is complex and variable, many changes in conditions will cause the deformation of the welding lens, which makes the welding lens deviate to the welding position. If the welding robot cannot adjust it reasonably, the welding quality may be greatly reduced. Therefore, high measurement sensors must be considered. But the cost of using these robots may also increase greatly. How can we find such a balanced point is very important. Leading error of the visual tracking system. Since high-intensity light is generated during welding, if there is a high-intensity light on the welding workpiece at the current position of welding, its intensity will cover the light on the welding workpiece, and it is difficult to extract the relevant information from the network. Therefore, the current vision sensor may drive the welding torch to a certain distance, which will introduce fault errors. In the actual welding mode, the main error may affect the welding effect. Research on welding robot vision system and Da-Xgboost algorithm, problems in the image target detection of the visual tracking system. Background modeling. In the computer's field of view, if we want to detect the moving target we are interested in, we must highlight the area of interest in the field of view, that is, target detection. In the process of target detection, background difference technology and detection of moving targets in complex scenes are often used. That is, interest in external conditions such as cloudy sky, leaf shaking, camera movement, light changes, and local background movement outside the target background. In this case, how to quickly create a stable and dynamic background is still difficult. Foreground segmentation. The foreground target area obtained from the commonly used background contrast technique mainly contains moving shadows. Since the shadows generated by these target movements have the same motion pattern as the foreground targets, the difference technology cannot correctly classify the foreground and shadows. Wrong shadow classification will lead to the accuracy of subsequent target tracking, number estimation, and gesture-based behavior recognition. Robustness problem. In actual work scenarios, a lot of work is needed to extend the theoretical scientific research techniques obtained from laboratory research to complex practical applications, which requires the system to have a high degree of adaptability. Generally, This system needs to be able to run automatically and continuously, and this practical application requires that the video surveillance system is not sensitive to factors such as noise, light changes, and weather conditions. The detection effect of the shadow area is easily affected by the lighting and difference effects, so these problems must be solved in practical applications. Feature extraction. At this stage, the commonly used functions of image detection technology include color, physics, geometry, and brightness. However, since each function is suitable for different environments, it is still difficult to find the best function for a specific application. Performance evaluation. The durability and accuracy of image target detection are important indicators. These systems can resist noise, whether they have target independence, scene independence, and balanced computer load, and this system can detect indirect shadows and direct shadows. These complex and constantly changing problems make surveillance technology more awkward, so there is still a need looking for more effective shadow detection benchmarks. Research on Welding Robot Vision System and Da-Xgboost algorithm. The composition of the machine vision system, light source system. The use of a reasonable light source system can highlight the welding workpiece from the background, enhance the recognition of the edge of the welding workpiece, and simplify the difficulty of the image recognition algorithm used to extract the welding workpiece or determine the edge of the welding workpiece. In order to achieve this goal, it is necessary to consider the interaction between the light and the welding workpiece, including the color, direction, polarity, intensity, and uniformity of the light source. Acquire images. The imaging part is usually composed of two parts of materials. One is an optical photographic lens and the camera. The camera of this machine is composed of one or more groups of concave and convex optical camera lenses. One of its functions is to display the shape and image of the object on the level of the camera sensor. The quality of the optical lens directly affects the visual display quality on the sensor plane. This is a system component that affects the physical measurement of electronic sensors, determine the quality of the entire optical system. Therefore, it is necessary to consider choosing a lens with reasonable parameters and high quality. The main parameters of the lens include aperture, focal length, field of view, working time and distance, optical parameter curve, and so on. The focal length determines the angle of view in the imaging system. Digital image processing. Generally, digital image processing is performed by running a program written by digital image processing software on a computer or by writing an image processing algorithm to a specific processor. Compared with the two, the former is more widely used. Use digital image editing software to compile programs through PC, edit, draw, enhance, segment, export features and other image processing, extract useful information from digital images, and perform digital editing process images. Calibration of the vision system. After building the system platform, the system must be calibrated before use. The calibration of the entire robot welding system mainly involves three aspects: robot body calibration, internal camera parameter calibration, and anti calibration. Among them, the body calibration of the robot is usually completed by the manufacturer, so the experimental platform only needs to complete the calibration of the camera's internal parameters and the calibration of the hand and eyes. Design of welding robot vision system based on Da-Xgboost algorithm. The visual sensor and the diagonal welding gun of the system are respectively installed on two sets of diagonal sliders. The moving position of the welding gun is automatically adjusted by two sets of diagonal sliders. The two sets of motors can drive the diagonal sliders. In the process of welding operations, the CCD camera will directly collect structured light and shadow and electronic images from the slot, and send these analog signals to the image capture card on the electronics and industrial computers. The video card directly converts the analog signal into a digital signal, and then performs a series of image processing through an industrial computer. Calculate the position of the welding lens in each weld, calculate its deviation, and send these deviations to the LabVIEW multi-axis motion control card, and drive the transverse controller or the robot motor according to the specific control strategy. The deviation behavior is finally eliminated up. The cross slider is composed of a motor and a screw connection, as shown in Figure 1. It can be seen from Figure 2 that since the actual coordinates and the robot motion coordinates are obtained by manual measurement, there is a certain error, even in this case. The absolute error of the entire vision system obtained is not more than 0.5 millimeters, which meets the requirements of system application. Conclusions. As a traditional part processing method, welding technology has an important position in our country's machinery manufacturing industry. In addition to parts assembly and machining, it also ranks third in welding. With the development of advanced manufacturing equipment and technology, it is becoming an inevitable trend to realize the intelligentization, automation, and flexibility of welding equipment products. The use of robotic welding technology in welding operations has become an important symbol of welding operation automation. The welding robot not only makes it have good running stability and high production efficiency, but also reduces the workload and can adapt to all kinds of harsh operating environments. They are widely used in civil fields, such as ships, automobiles, chemicals, oil refining, metallurgy, pressure vessels, machinery, aviation, and other aspects of engineering and construction. Although our country has become a large country in construction and production, the level of intelligent welding technology in our country still lags behind that of developed countries. The strong progress of intelligent welding technology is an important key to improving the technological level of our country's industry.